Now learning outcome 1.2 electric field. Example 4. Determine the electric field strength at a point X at a distance 20 cm from a point charge Q equal to positive 8 microcoulomb. B. The electric force that act on a test charge Q naught equal to negative 1 microcoulomb placed at X. Step 1. Draw the electric field diagram acting on point X due to Q point charge. As you know, electric field for a point moving away for a positive charge. So the direction at point X to the right, you label as EX. Second step, by applying equation for E equal to KQ divided by R squared, calculate the magnitude of the electric field created by the surrounding for a point charge. E equal to KQ divided by R squared. Substitute your K 9 times 10 to the power of 9 multiplied by 8 times 10 to the power of negative 6. You divide by 0.2 squared. You get a E equal to 1.8 times 10 to the power of 6. Newton coulombs negative 1. The direction is to the right. B. Electric force F equal to QE. Your Q naught here is 1 times 10 to the power of negative 6. You multiply by electric field produced by a point charge equal to 1.8 times 10 to the power of 6. You get a F equal to 1.8 Newton. Why to the left? Because the point charge and test charge is opposite direction. So the force acting is attractive force. That means to the left. Example 5. You have a 2-point charge Q1 equal to positive 7 microcoulomb and Q2 equal to negative 5 microcoulomb are separated by a distance 0.3 meter between each other as in a figure below. Determine the resultant of E produced by these two charges at a point P. First step. Draw the electric field E diagram produced by Q1 and Q2 at a point P here. E1 is produced by a Q1 and then E2 labeled as E2 is produced by a Q2. How you can draw the electric field? Please remember when you draw the electric field is outward for a positive charge. So, positive charge for a Q1, upwards. So, you label as a E1 like this one. So, E2 is a negative charge. That means inwards. You label as E2. Vector electric field is a draw along the line that joining point P and the charge. Step 2. Apply E equal to KQ divided by R squared. Find the magnitude of each electric field created the surrounding point charge. E1 equal to KQ1 divided by R squared. Substitute the value K 9 times 10 to the power of 9 multiplied by 7 times 10 to the power of negative 6 divided by 0.4 squared. You get 3.93 times 10 to the power of 5 Newton coulomb negative 1. Then for E2 equal to KQ2 divided by R squared. Substitute the value 9 times 10 to the power of 9 multiplied by 5 times 10 to the power of negative 6. You divide by 0.5 squared. You get 1.8 times 10 to the power of 5 Newton coulomb negative 1. Please remember, no need to substitute negative sign for a negative charge. Step 3. Consider the direction to get the resultant. Since E is a vector quantity, so we have to resolve E1 and also E2 into X and also Y component to find the summation of each component. Before you solve the problem, you calculate the value for theta for E2. By tangent theta equal to 0.4 divided by 0.3, you get the theta 53.13 degree. You resolve the component E2 by component X and also Y component. Then substitute into the table. So E1 for X component equal to 0. E1 for Y component equal to 3.93 times 10 to the power 5. And then E2 here for X component, 1.8 times 10 to the power 5 cos 53.13. You get 1.08 times 10 to the power 5. E2X component. Please remember your E2 negative 1.8 times 10 to the power 5 sine 53.13. Negative here, you get 1.44 times 10 to the power 5. And then you get the resultant for EX equal to 1.08 times 10 to the power 5 Newton Coulomb negative 1. Resultant for Y component equal to 2.49 times 10 to the power 5 Newton Coulombs negative 1. Therefore, the magnitude of resultant for E equal to square root of EX squared plus EY squared. Your EX squared 1.08 times 10 to the power of 5 square plus 2.49 times 10 to the power of 5 square. You get the E resultant 2.714 times 10 to the power of 5 Newton coulombs. How about the direction? The direction of the electric field is given by tangent theta equal to EY divided by EX. And then substitute value EY 2.49 times 10 to the power of 5 divided by 1.08 times 10 to the power of 5. You get the theta 66.64 degree. Please remember, write down the notation for above the positive x-axis.